In today's session, we're going to continue on the implementation process to achieve breakthrough improvement. So at this point in the implementation, the system should be stable so that we know where the constraint is. We strategically position the constraint. Now we want to focus on, is there a significant need of the customer that we can take advantage of to improve our operational performance for the same operating expense? So if we do that, then we can increase our profitability, reduce our lead times, reduce our inventory, right? All the financial and operational metrics improve for the organization. So now we're going to focus on leveraging that protective capacity. So every operation in the workflow has variation. So if we look at each process step, there's variation, and that variation comes from stoppages in the workflow. So that can be due to resources not showing up for work. It can be due to quality issues. It can be due to doing rework on those operations. It can be due to resource downtime, not having full kit. All these things disrupt the flow. So we're going to look at the variation in the system and understand how can we leverage that protective capacity by reducing variation. So we also have variation between the value-added steps, but if we put in standard work in process, that variation between the steps becomes highly predictable, so we can control that variability. Now we focus on the value-added steps to reduce the variability there. So if we look at the operation, we have unbalanced capacity, so that means we have a single resource that's the capacity constraint. It's the resource with the least amount of capacity in the system, and we have variability on all these process steps, and we have protected capacity to overcome that variability. So my general rule of thumb, minimum of 20% protected capacity if you've done no process improvements to reduce variability. So now, if we look at this system, we need this protected capacity because we're still going to have issues and we're still going to have resource contentions, but we can become stable given this variability in your current system. So now, reducing variability, what we want to do is we want to increase the overall capacity at the capacity constraint. So it's where we want to reduce variability, but also when we reduce variability, we require less protective capacity on non-constraints. So this is a key understanding here. Less variability in the system, less protective capacity required to maintain stability. So now our definition of focus, doing what should be done, not doing what shouldn't be done. So focus becomes where it's important to reduce variability, which is on our capacity constraint of course, and then the resource with the least amount of protective capacity, we want to focus our efforts there to reduce variability there. And then where it's not important to reduce variability is all these other resources that have sufficient protective capacity. So now we're going to be applying our focus in the right areas. So now what we want to do is if we reduce the variability on our capacity constraint resource and the resource with the next amount of least protective capacity, then we can get overall performance improvement while still remaining stable and actually reducing lead time even further. And if lead time is a significant need of the customer, we can leverage that capability in the market. So now we focus our variation reduction here. We increase our capacity of our whole system while maintaining stability. And again, we continue to go through this process of focus, where it's important to make changes, where it's not important to make changes. So now we really get our resources dialed in on the critical things we need to be doing as an organization to satisfy those significant needs of the customer. So that's our session for today. Again, connect with me on LinkedIn, visit our website to see all the types of services we provide and the training that we provide to help organizations become high performing.